Okay, good afternoon. Welcome to day 2. My name's Andrew Westgarth. I'm a principal product manager on Azure App Service. I've had the joy of being on the team for a little over 11 years now, so there must be something good about working with the team. Either that or they just can't get rid of me. And it's a lot of fun. And the great thing about it, I was thinking about this last night as I was preparing this talk, in that App Service can help you host applications right from things that you were doing maybe 20 years ago that you'd like to forget about, all the way up to the very latest stuff that's coming out now from our team and from other providers as well. So it's really quite a broad service to be able to host a multitude of applications. So today, what I want to go through is give you an example and some demonstrations about how we're making Aspire be deployable on Azure App Service as well. We've worked with the .NET team ever since Aspire came out to basically look and see where the other platforms are that we could actually deploy to, and Azure App Service is one of Azure's most popular services, so obviously we were looking at that as a target. So I'm going to go through there and show you how to do that, the minimal changes that are required. Also, I'm going to give you a sneak peek of things that are coming. I was given access to some drops last week, and I'm going to show you the direction that we're headed in so that you can see that the preview has moved on a little bit further since May, when we announced. Then we'll have a look at, we've got some AI examples with a inventory store with some open API endpoints, and then we're going to attach that back with using MCP to then tie that in, and we have much more of a conversational AI experience in our app, and we'll show you that up and running on App Service and all the different pieces and how they work with AI Foundry, how it's secured, etc. And we'll go through and look at logging as well, something that's incredibly important. So first, you've heard a lot about Aspire this week and previous weeks beforehand. I must admit, I'd forgotten it had been announced as long ago as it had, and it went GA over a year ago. But it's very much a cloud-native distributed stack, so very much focused on you being able to bring it to whichever destination that you wish to, but be able to build distributed applications very easily and simply up front with things that we've learned from both our customers, but both of our experience of actually building large distributed applications for many years. The developer experience is simplified in that you can plug and play different NuGet packages. So maybe you want to use Redis cache, or maybe you want to use Postgres, then you can plug these into your Aspire app host and have the flexibility and the functionality built into your application straight away. And one of the key things that I love about Aspire is the local monitoring and debugging experience. That dashboard, that's a killer feature for me. Over many years prior to my life at Microsoft, I built large-scale systems, and logging was always an afterthought by many teams. But it's absolutely critical when you've got an application out there and you need to be able to understand what's going on, where you're stealing bytes, where there's slowdowns in your applications, and to have that rich experience within Aspire out of the box is very, very transformative, in my opinion. So Aspire came out, and it was made available, and it immediately deploys to one of our sister services, Azure Container Apps. But we had a huge amount of customers saying to us, no, we want to be able to run Aspire workloads on App Service. Can you make that happen? And so, like I said, we started conversations around about when .NET 9.2 came out. We started conversations with the .NET team about making sure that App Service was a good host and a target for Aspire workloads. So there's different ways in which that App Service works compared to, say, ACA. ACA is built on top of Kubernetes. App Service is built on top of Windows and Linux hosts, and so therefore there's very different experiences in how we actually put stuff together. Traditionally we only do north-south routing. So in, out with App Service. We don't allow east-west, so you don't have an application on one instance talking to another instance like you would in pods in Kubernetes. So there were certain things that we needed to do there. The benefit of using something like App Service is that we are literally global. We are in every data center that Azure is hosted in, and as soon as a new data center comes up, we're about third or fourth service that comes online after foundational services. So we're a high-scale, highly managed platform that allows you as developers and business owners just to focus on your applications and add business value. We recently announced the general availability of our premium v4 plans. So these offer significant improvements on top of what we already had with PV3, Basic, and Standard. And additionally, I'm going to get into it in a moment, the changes that we've made in terms of availability zones for high availability. So you've got an extremely high availability platform, global reach, be able to deploy to multiple regions, all while we'll manage the infrastructure for you. App Service Premium v4 was a new SKU that we announced at Build, and it went GA around about the 1st of September. And it offers 25% improved performance because we're running on the latest hardware that Azure can provide to us as a service inside Azure. So that provides you with a lot of new capabilities. So just from going from PV3 to PV4, you immediately get a performance improvement. In addition, if you're on Windows, so it's not necessarily directly relevant to Aspire today, but if you have Windows workloads and you want to run those on PV4, you make a massive saving of 24% before getting into things like reserved instance pricing, where we can give you an even bigger discount if you're going to make a commitment to actually use App Service for 1 or 3 years. So it's a pretty big thing there. We are rolling it out globally. It takes some time. You know, the last count that I remember us discussing, App Service was running on well over more than 2 million machines globally. So for us to add a new SKU takes a little bit of time, but we're growing in a number of regions that we have PV4 in place. So it's something you can take advantage of today. Availability zones are a great way to provide resiliency for your application. Up until about 6 months ago, we required you to actually deploy to 3 zones. So a data center within Azure is split up between 3 availability zones, which provides you with resiliency inside the data center. And so we had a requirement within App Service that you actually always had to run on 3 zones if you wanted to take advantage of resiliency. So what does that mean? What it means is that should you lose one of those zones, we maintain that we will maintain your SLA and keep your applications up while, say, a third of the data center is inaccessible. So while we're fixing a problem on the back end, you can be sure that your application is still up and serving requests outright. They're available on premium and isolated SKUs, so it is very much seen as a premium feature, and it's something that's hidden from you. We deal with it as a platform. We make sure that when you say to us, I want to be zone redundant, we place your application on the relevant racks inside a data center to make sure that you're protected from failures. Before May, you had to be deployed on 3, as I mentioned. So it required a minimum of 3 instances straight up. So it put the cost up quite significantly for you to host a zone resilient app. What we announced earlier this year, and is now GA, is support for 2-zone enablement. So it means now your requirement is down to 2 zones. You get a greater improved SLA, so 99.99 uptime. And I think this was missed inside our announcements. We allow it to be turned on and off. So if you have an application, for whatever reason, you need to scale down on a weekend and you don't want to be paying for 2 instances, so you got zone redundant, you can turn off zone redundancy, scale down to 1, then before Monday morning comes back on when you need to be mission critical again, you can turn zone redundancy back on and go out to 2. And ACE can have a mixture of zone redundant and non-zone redundant. The zone redundancy is set at the app service plan level, so then you have a consistent experience there. But let's have a look at Aspire on App Service and see what it takes to actually get Aspire running, and I'll also give you an example of where we're going with it next. So I'm going to do the canonical hello world for Aspire. So I'm just going to create a new solution. So that's just pulling in all the packages that I need. Simple application up and running. I'll just do a .NET restore. .NET build. Something's gone cold on me. This took seconds upstairs. And then what I'm going to do is I'm going to add this package. So, oh, excuse me. Nope. There we go. So what I'm doing now, in 9.3 of .NET, they added the concept of publishers. And so this is how we're able to add App Service to support to that, because we've been able to build an App Service publisher. And so all I've done here is I've added the package to the App Host project. So the App Host project, if you've seen it in the demos for Aspire so far this week, is kind of the nucleus of the orchestration and of all the service enablement within inside Aspire. What I'm going to do is I'm going to open up that project. And if I go into the app host, we're going to make 2 small changes so that I can actually run this and deploy this within App Service. So the first thing I'm going to do is I'm going to add to the builder object, tell it to add an app service environment. So that tells me that I'm going to deploy this project to app service, and that I need to have that up and running. Why is it gray? So there we go. And then the next thing I need to do, this is a current limitation. We need to expose the API service with HTTP endpoints. Because we don't have everything set up yet with private link and things like that to be able to have all of that traffic internal. So what we're working on future is to make that by default out of the box, secured by private link, so that the API service that you get with Aspire is not exposed publicly, and so your web front end talks to the back end through private link. Nice and tidy, nice and neat. And that is all I needed to do now to actually have that up and running. So what we're going to do now is I'm going to tell AZD, or AZD from where I'm from, to go and initialize that directory and go and figure out what it is that I want to deploy. Oh. Okay. There we go. Typo on my end, my apologies. If this takes too long, we'll go to my Blue Peter version, i.e. one I made earlier, and we'll just show it off. Confirm. Okay. Yep. So I'm choosing to deploy to my MSDN subscription. We're just going to choose the defaults, West Europe. And then what I will do is I will go here and refresh. We should start to see the Aspire app come up in just a moment. Now, the one thing to point out is I can run that application locally, and that's fine. I can view the dashboard, etc. It's not a problem. But when we're in App Service today, the current limitation of the current preview is you won't get the dashboard. You'll get the API application, and you'll get the app host, but you won't get the dashboard out of the box. That's a slight limitation of where we are today, but as soon as I prove this app is up there, we'll have a look at one that's actually running. No, right. We're going to go to, I'm going to rethink my demo, and we're going to go to another one that I've got here. Aspire. There we go. So this is an application that I previously set up, and this is an Aspire. No, this is not the app that I wanted. Sorry. It's flailing. Here we go. Sorry about that. Just had to find one of the many thousand applications that we have. So this is ASP.NET Aspire in-app service, the way that things stand today with the current preview. So you'll see here that I have the web front end and the API service that you get by default out of the Aspire template. That then uses a managed identity to talk to the container registry, which is where we push all the artifacts when we do AZD up, and we build all of those for you. Where we're heading to, and this is the thing that you'll see next, this you'll see more of in the next few weeks. This literally landed on my desk, my metaphorical desk on Friday, and you'll see now we've got a new resource type, which is an Aspire dashboard. So on this web app, I can actually view the dashboard. So if I view the web front end, browse to that, you see the canonical example that we have with Aspire. And then what I can do with this one, this is the direction that we're heading in with App Service, is I can go and view the dashboard. And I can go through, look at all of my traces, see all that traffic that's flowed through during the time that I've had that application up and running. If we look at the JSON view, you see what we've actually done is we've created a new website, and we've added a new kind. So within App Service, if you're used to ARM, you'll see that we have things like app Linux, app Windows container, that sort of thing. And now we have a new kind for an Aspire dashboard that will start lighting up in the next few weeks and months. And you will see more of this at .NET Conf in the beginning of November, and then more again when we talk about it more at Ignite and places like that as we go forward. I apologize for the first demo, the basic demo failing as much as it did, but I wanted to get to this point so I can show you the direction that we're heading in to show that the preview has expanded on where we were. And if we switch back to the console, yeah, that application is now deployed. I've got the service front end and I've got the API service, but because we're on the old preview, I don't have the dashboard there. Let's go back to the deck. OK, so we've proved we can host Aspire on App Service. So what next? Well, the next thing we want to talk about is how do we take advantage of OpenAPI and MCP while running on top of App Service. This demo is going to show off using ASP.NET Aspire, but it can actually be used really with any application that exposes a web API. If you can provide an open API spec, then you can then wire that up to AI Foundry. What is AI Foundry? So AI Foundry is a suite, if you like, of functionality and capabilities that you can use to integrate your apps with to then generate agents. So you can build using system prompts. They've got memory configuration. Use OpenAPI specified tools to interact with your APIs that you already have within your applications and then make them available to LLMs, make them available to conversational agents. We secure authentication to AI Foundry using managed identity. So that's one of the benefits, again, of using App Service. We provide managed identity support out of the box, whether it's system or whether it's user. You register an API via an OpenAPI spec to allow the agents to be able to invocate operations on your behalf. And then you can scale these agents as much as you need. To do this, to connect ASP.NET Aspire, .NET Aspire and OpenAPI tools, we attach them with some annotation on the API. And today I've got a Python API that I'll be able to show you in the code how we've decorated that. And then we register that with AI Foundry, and then the agents invoke through AI Foundry, and that's where we secure the communications. Model Context Protocol defines how your AI agents interact with tools using standardized transports like HTTP. They provide a way for your tools to discover and invocate the APIs and enable you to use multiple different clients via the MCP server to actually interact with your APIs. So you see things like in demos that we've had today. We've had clients like VS Code, or we have other web applications, or we have maybe a mobile applications that's invocating MCP servers. And it simplifies integration because you're going through one endpoint, one protocol, rather than having to produce different implementations for different endpoints. App Service can provide you a home for your own MCP servers that you produce. If you're using .NET, you can use the Model Context Protocol NuGet package to be able to build out your applications. You can expose those through HTTP. That's what App Service does. App Service is a HTTP-based platform. All endpoints must be exposed via HTTP, HTTPS. And then you can then integrate that directly with your different toolings, your different experiences, your different agents inside an application, and then take advantage of the fact that you're on the App Service platform. So as your service becomes more and more popular, you can scale out your front end, you can scale out your APIs. because we can use things like automatic scaling, or we can have you regional deployed and then traffic manager and things like that in front of it. So once you're in that ecosystem, it gives you the ability to be able to scale out as far as you like. We've covered security. You can secure your invocations through managed identity between the inventory service, say your web front ends, any other services that you have running. You take advantage of integration with Azure Monitor, Azure Log Analytics, all of the plethora of capabilities that you have inside a managed platform like App Service to be able to build out these capabilities. So the example we're going to look at today is a multi-agent system. And we're going to talk in a couple of slides about why that's important and why is it important to choose multi-agent versus single agent. So in the example today, we have a multi-agent AI system. We have a web front end that then talks to a fashion store orchestrator, which determines which tooling and which agent to go through. So we have an inventory API which exposes an MCP endpoint. So that inventory API can then provide information back about how many items I've got in the back in the locker ready to take orders for. But then it can talk to additional agents like the cart manager, and the cart manager will determine what's in my shopping basket already and whether there's something else that might be complementary. My fashion advisor, which is using pure AI, is going to say whether something matches or not. I always joke with my wife, up until about 10, 15 years ago, I used to just buy large of everything. And then I realized maybe that's not a good idea. But, that's what I used to do. Maybe now with an open AI fashion advisor, it might actually tell me, well, you're 5 foot something and you weigh about as much as a wet rag, so maybe you should actually wear something a bit smaller. And then we have content moderators. So one of the fears of AI is, well, the quality of what you get out is what you put in, but also can it be abused? So we can use the AI inferencing to actually look at the content that's being passed through and see, is it valid, is it something that we want within our ecosystem? And then finally, the cart manager talks via an open API tool to the cart management API. This diagram just highlights the tools that are involved. So as I mentioned as we were talking, the first tool with the orchestrator is the connected agent tool, which links out to specialist agents, and we've got a few here. The MCP tool for the direct inventory access. Cart manager uses open API. The fashion advisor is not using any API at all. It's using pure AI functionality that we're taking advantage of the model that we've deployed. AI reasoning for content moderation. So why use single or multi-agent? So in the demo that we've got here, we're using multi-agent, but it's pertinent to talk about why do we use single and why do we use multi. So for single, you can think about it as a monolithic path. So it's one way through, it always has to invocate every single step. Single agent-based flows are important if speed is absolutely critical, because it doesn't introduce additional latency. Is your workflow simple? Is it straightforward? Is it repeatable? Do you have a small team maybe? You don't want to be managing multiple agents and multiple different elements of expertise. Cost optimization. So if you want to keep costs short, costs small, costs low, then maybe you're going to go down a single agent route. Conversely, multi-agents provide more handoffs, but therefore higher latency, because you have to go through multiple different agents, and each one of those agents could have bottlenecks or different experiences. Conceptually, they're fine-grained. So it means that you can have much more control about what each individual agent does. And the benefit to that is if you need specialization in a particular domain area. So say you have some particular business logic that you need to run in one agent, but that domain knowledge is not shared across your team, so you might be split into multiple teams. For compliance needs, you might need to run different agents. And complex workflows. They're more composable, but they're more work. So it's a trade-off, as most things are in software development. So let's have a look at this demo. So I'm not going to put you through watching deployments and things like that. I only really wanted to show that experience with the Aspire project because it's new. That app service integration is not something we've spoken about a huge amount, but I wanted to give you an example of how little you needed to do. So what I'm showing you here is just some pre-work that I did earlier today. So the first is, at the top, we have this inventory web application. So this is my API. So this is talking to my back-end product store to say how many items of clothing of a particular type do I have in stock, and can I get those, and can I use them, and can I sell them? And then finally, at the bottom, we have a project that it has got agents in, and this is a Python agents project. I've gone ahead and deployed these already because I didn't want us to be sitting waiting for those to go up. The agents project alone, because it creates an AI Foundry resource and a model and things like that, that can take 5 to 10 minutes depending on your connection and where you are and what's going on. What I've done then is I've set some environment variables of the inventory URL, the deployment name of the model. Now, we could change that to GPT-5, but I've been working with this before, so I'm not going to rock the boat too soon. But you could certainly do that. That wouldn't be a problem. I've got the web app URL, so this is the front end to the application. And then I've got a project endpoint. So let's see where we are right now with the application, and I'll show you the functionality that we have already. So if I just look at the tags here, so I get the right one. That's the inventory API. So we browse, and this is my inventory API. This is now exposed to the MVP server, so I can connect to this from VS Code, or I can connect through AI Foundry. And you see it gives you an example of what it's doing. It's populated with dummy data, of course, but it gives me an idea. I've got these products, and I've got how many sizes and how many items available. And then equally, this page demonstrates what the operations I have available that I'm going to expose to that MCP tool to be able to query and invocate. If we have a look quickly at the main Python file, you can see here that we've decorated our API routes throughout, and then we also have decorations for all of the MCP workloads as well. There we go. So our MCP tool functions are highlighted. We've got those in place. I've got those output. And now I can expose those to the MCP tool inside AI Foundry. I now switch to the front-end app, and you'll see here that it's if I expand the source, we've got my familiar app host file, app host project, the service descriptors, and then my front end, my fashion assistant, my storefront for my web application, all wired up using Aspire. I could run that locally, and the only thing that would fail there is I can configure it to talk to the inventory URL. So if we go to this file here, and I take that out, and I go and get my inventory URL, I can run this locally, and then what it will do is it will talk to the inventory service that I've deployed up into the cloud. I can't local dev the AI experience because I need to be in Azure to use that managed identity that I've enabled on the web app in App Service. Now here I have the dashboard, because I have everything local, so I can use the dashboard and I can make use of that. If I then browse to the web app, so as I say, I can say hello to this, but it's not going to respond to me. We're going to add that next. But I can go to my inventory, I can see what I have, I can add that to my cart, and I can test that the core functionality of my web application is working locally. Now we're going to go and plug in all of the agents so that we can actually take advantage of the full resource. This sample is available to you in Azure Samples. We published this recently. So you can get, after the session, you can take this away and go and deploy exactly what I'm doing today up in the cloud and explore and modify and tailor and tweak with the project. You know what? No. I'm not going to put you through that. I'm going to go to... Okay. There's too much red, so I decided to step out of that and go back to one that I made earlier. I apologize for the failures in those demos. This is the resultant application. What I'd actually deployed, what I was planning to do there is to demonstrate using a Python script to go and set up 4 agents with inside AI Foundry. And we're going to go and look at those. But what I really want you to leave today with is seeing the application up and running, seeing the invocation, seeing the difference between invocating one agent versus using the MCP orchestrator to go and invocate multiple agents in the flow. And increasingly more important, I want to show you within AI Foundry how you can then troubleshoot and see that conversation and how it flows through each individual agent, and the experience to be able to debug, to be able to trace through that, to be able to play with it. What I didn't want you to see is me have typo issues. What I want to try and get across is the message here is that with these agents, you're adding functionality and you're adding capabilities, and I want to give you the tools to be able to see how you secure those, how you look through the log telemetry to be able to add the value, not see where odd typos are causing me problems. So let's start again. So I've got my agent up and running. This has the agents on the back end with that architecture that we went through with the diagrams. And you see this chat is active. So this is actually deployed, wired up. There was only a few more steps that I needed to go through, but I'd rather spend time doing this. I could go to the inventory and go and troubleshoot it and interrogate it that way. I can go into my cart, the checkout functionality is there, it all goes through fine. But the whole idea of adding these conversational agents is I can just have a chat with the agent, like Scott, the 2 Scotts were talking about this morning. So I can now go and talk to my program, I can go and talk to my store, I can give it some requirements, I can talk through what I want. So let's see. Tell me, do we have any Blazers in stock? So now that's going to go and talk to the orchestrator endpoint and decide which of the agents does it need to use to solve that problem. So it's told me it has one Blazer in inventory, it's a navy single-breasted slim fit, and sizes available, we don't have any. So that gives me a bit of a false positive. But it does give me the option to have a notification of when that comes back in stock. So I'm actually going to say I need an outfit for tonight at the attendee party. I need an outfit for a casual reception. Provide me with some options. Note at the top, each one of these conversations has a thread ID. That thread ID we're going to use just shortly to go through and do some more investigation using that thread ID. So that's come back. The fashion assistant plus the product information is able to come back and say, these are some options that you want. So I'm going to say, I would like a navy and blue shirt. Please add a size small to my cart. So now I'm invoking multiple agents because I'm checking to make sure that we've got inventory. Have we got that product? Have we got that size available? And then the cart API is triggered to be able to say, put that in my basket. Everything's selling out. So now I'm going to ask, well, what is in my cart? I lived in the States for 7 years, so going to a store and finding that nowhere had a size small was quite a common experience. Try and get a belt in a size small, and it's just a non-starter. So there we go. So now it tells me that actually I did put one of those before, so I'd exhausted the inventory anyway. So that was my own fault for seeing that fail. But what I want to show you now is, well, okay, that's great, and I can see that the AI agent is adding value to my application. But say something went wrong. How do I replay that conversation that a customer had had? How do I see that the inputs that they'd put in place, and how do I see where it went? So you've got a complex workflow and it did something you didn't expect. How do you figure out where in that workflow did that come from? So we're going to look at this thread. So end in WJAS. And I'm going to switch to the AI Foundry instance. I've drilled down into my project. I'm going to go into the project. And we're going to use the AI Foundry portal. So this is another portal in addition to our common Azure portal. And within here, I can find out a huge amount of information about my application. I can handle my security. I can look for my API keys, look at all my agents. So just to prove that is the agent that we were working with. There's the agents that we deployed. So we've got the fashion store, the content moderator, cart, etc. But what I want to go to here is the threads. So if we go to the threads, and then what we can do is we can try in the playground. So inside the playground, we can see the various different flows that was happening in that conversation that we had back and forth, me as a user. So this is a way that you can provide like a correlation ID from a support perspective that you can then retrieve from your user to figure out where the agent went and where you can see and you can replay back. But equally, if I go through and look into the thread logs, I can see each individual invocation. So I can see the thread that was started. I can see the run, which was the operation that happened. I can then see the run step. I can see the tool calls, which tool was used, whether it was OpenAPI, whether it was MCP. And so I can see from here, with my run, that's what was put in terms of the prompt that the user provided. I can see the output that came from the instance. How did we do that? So we provided the input and the output, and then the tool calls. So we can see from the tool, these were the steps, these were the tokens that we required, when it started, when it finished, did it complete, did it not? And then I can see the tool that it actually called out to. So in this case, it went out to the cart manager and it called the add to cart functionality. So I can see this all within inside Azure AI Foundry. In addition to this, if you wish to take it further, you can add app insights to your model, to your agents as well, through AI Foundry. And then you can see resource usage. So you can see number of requests that we've put through, time it takes, latency metrics, time to last byte, etc., as you go through and add more. And going back to, if I look at the access control on this, and we go to check access, show managed identity, we can see the app services that we had running, app web IZ, that one. So I can see there that it's been secured using the managed identity that's assigned to the web app. So all the communication between the web app and the AI Foundry endpoints is all using managed identity, so we're keeping everything secure. We're not passing around large passwords and connection strings and things like that. We're doing everything through managed identity. So getting close to wrapping up now. But the security and networking considerations that we called out there was that we can secure those APIs through private link. So your inventory API, we can hook those up through private link. We can keep all the communication within inside the VNet. We can use managed identity to provide communication, be that from the web app to another Azure resource or to your Azure AI Foundry resource. We can then control and rate limit on those applications. And then we can also have secrets management. So capability within App Service that we have for secret management is we use Key Vault references. So you can store your secrets inside Key Vault, reference them as environment variables, and then at runtime, we evaluate what they are from Key Vault. You maintain them in a secure manner. You don't have any individual actor just randomly having to have full access to the web app to manage environment variables. You can do that through Key Vault. Using OpenTelemetry by default outside of Aspire, you get full, rich logging and integration and telemetry out of your application. You will, as I've showed and demoed, you will start to see that dashboard resource as well show up in App Service. So you'll have that full experience in production as well as locally in development. Then added onto that, in AI Foundry, you can add telemetry and tracing with inside your applications out of the box so you can see what your agents are doing, what the invocations are, troubleshoot throughout. So we've briefly gone over the Aspire architecture overview, and I've demonstrated how you can host Aspire on App Service. Relatively small amount of changes. It's currently in public preview. I don't anticipate it will be in public preview for too much longer. We're looking to try and get that to GA at some point soon for you as customers to take advantage of. That preview that you saw, that will be starting to roll out, and please do keep an eye on .NET Conf and Ignite, and you'll see more of what's going on there. Leveraging App Service for any web workloads gives you an ability to actually scale at a huge amount within a couple of clicks. It's not a case of you having to go and spin up individual environments, resources, that sort of thing. So for Aspire, where you're building these large distributed applications, the power of App Service really will come to bear there in being able to scale and grow regionally and globally. Integrate directly with AI Foundry from App Service, because we've got the managed identity support out of the box, the ability for you to host your APIs and then expose them with HTTP endpoints with very limited work, very minimal work from your end, and then hook them up into AI Foundry, build agents, expose those through MCP or OpenAPI, and you're adding value all the way along. And as I say, that demo is using Aspire. We have other demonstrations that just use a simple web API. There's no reason why you couldn't do that as well. You provide an OpenAPI spec, and then you can expose those and use those with agents. Using a managed platform like App Service, you get the full capabilities of security and observability, whether that's through Azure Monitor, log analytics, using managed identity, using private link, keep all of your traffic within inside VNet. So it's a great host for you to run a lot of workloads, and this demonstration today was with the AI Foundry. Further learning and resources. So there's all of the documentation for Aspire App Service. This link here, aka.ms, Aspire on App Service, is a link to a blog post of how to get started with Aspire Preview on App Service. As and when we announce new things, so when we announce this new experience, I'll make sure that that link's updated with all the new guidance that we put out there. So that will be a live link. And then links to the AI Foundry. And finally, this is a link to Azure Samples. This is that eShop sample that I went through at the end, which is talking to the agents, which is talking to the inventory app, and it goes right from scratch. So right from the different repos that you need to clone, guide through each individual one, sets the environment variables, sets the resources, gets everything up and running end to end, and so that you can actually get this running inside your own subscriptions. And then it also has the guidance on looking at further detailed logging and telemetry that you can do with inside AI Foundry and with inside Azure Monitor, so that you can then start to apply those concepts into your own workloads. I have got 5 minutes, so if you've got any questions, I'd be glad to answer them, whether it's about what you've seen today or anything else related to, say, App Service. Yeah.
Yesterday I saw the
Yep.
she used different commands, Aspire directly.
Aspire CLI.
You use .NET Aspire.
So the question was, in Maddie's talk yesterday, where she went through Aspire, she was using the Aspire CLI, which is a new CLI that's just landed, I think. And I was using the .NET CLI so that I could actually stand up and run the projects. The Aspire CLI is cross-platform and cross-language, I think, whereas the .NET is purely for .NET. The reason I use that is because that's what I've been doing all of my practice with, and I got first access to Aspire last week, the CLI, so I didn't want to change everything straight away. But the Aspire CLI, from what I understand, will be able to do all of that and more, but the .NET one is purely for .NET workloads, whereas the Aspire CLI will target things like Python, Node, as they add functionality. The one thing I'll admit that I'm not clear on is, can that do the AZD deployment? Because the AZD does the deployment through Bicep. So it discovers everything, generates the Bicep templates, and then publishes those. But I can follow up on that, but I don't know the answer today. It does, yeah. It would make sense it does, because we're all part of one larger team, but I don't want to commit to something I don't know for definite, so yeah. If there's nothing else, thank you very much for coming to my session today. I hope you have a great rest of Azure Dev Summit. It's lovely to be in Portugal for the first time, and thank you for bearing with me with the demo snafus.